So, what is FactoryTalk Design Studio? FactoryTalk Design Studio is Rockwell Automation's new cloud-native industrial automation design software. FactoryTalk Design Studio is a new cloud-native software product from Rockwell Automation, built from the ground up to improve system design efficiency, beginning with controller and system design. Design Studio integrates modern software development workflows with tried and true industrial automation design. Users will be able to reduce development time and speed time to market, bringing automation programming into the modern software design environment.
FactoryTalk Design Studio is a new system-focused design product built natively in the cloud. Customers will benefit from modern software development practices like object-oriented and text-based programming. Although object-oriented programming is nothing new, object-oriented programming in automation space is. Design Studio uses object-oriented programming techniques with automation components like programs, routines, and add-on instructions. We have also seen that those new to the workforce coming from the educational environment are much more familiar with text-based programming. FactoryTalk Design Studio allows those users who are familiar with text-based programming to easily transition to automation programming, which has been traditionally done with graphical editors. And for those who prefer the graphical displays, the text is automatically rendered into the graphical display. This feature provides the flexibility for each developer to choose what programming method is best for them. As a cloud-native SaaS offering, FactoryTalk Design Studio is browser-based. Design Studio never requires any software downloads or installation. User access is through a standard web browser. This feature not only removes the user's burden of installing and maintaining the software, but also allows the anywhere at any time connection. Updates to the application are done automatically in the cloud. And another benefit for students is they will be able to access FactoryTalk Design Studio outside of the class and lab environment. When you are working in a system environment where there are multiple users making changes simultaneously, version control is critical. One of the key features of FactoryTalk Design Studio is its integrated version control system powered by Git technology. This integrated version control system enables native multi-user collaboration, allowing the user to easily share code while maintaining code synchronization. We will highlight some of these features when we share the detailed product screens. FactoryTalk Design Studio also includes integrated project tracking, allowing users to see all local and remote changes by other members of the team. You can merge your local edits with a shared project and merge changes made by other users. This feature provides design flexibility and improved collaboration while developing applications. Additionally, FactoryTalk Design Studio provides integrated library management, which allows users to standardize and reuse their code. These library objects will be used when implementing object-oriented code. With a system-focused approach, FactoryTalk Design Studio enables multiple controller management in a single project. Programs can be allocated individually to a controller based on the execution requirement of the project. This feature improves logical project organization and deployment. Rather than having to match the software version with a controller, FactoryTalk Design Studio can support multiple controller revisions and will inform the user when trying to allocate if the code is not supported by the firmware revision. This way we can use a single software across many hardware revisions.
Another benefit of FactoryTalk Design Studio, being a cloud-hosted SaaS offering, is the ability to provide updates automatically. FactoryTalk Design Studio has updates delivering new features quarterly. Since FactoryTalk Design Studio has been released in October of 2022, there has been several updates. These updates include new features like adding FactoryTalk Vault integration, device management, and configuration enhancements, and enhancements made to the version control system. For those who are familiar with Rockwell Automation's other design software, you may be asking where FactoryTalk Design Studio fits into that ecosystem. Rockwell Automation provides our users with an on-premises offering with Studio 5000 Logix Designer. For our Logix Designer users interested in moving to the cloud, we have FactoryTalk Twin Studio, which is cloud-hosted. FactoryTalk Design Studio is a cloud-native design application for users looking to adopt a cloud-native solution for their automation development.
Let's change gears here and look at some of the details of FactoryTalk Design Studio. The first item we are going to look at as part of a modern software experience is object-oriented programming. We are setting the foundation of object-oriented programming with a new object called a FactoryTalk Smart Object. During this presentation, we will just call these items Smart Objects. Smart Objects are containers. These containers can hold other smart objects, programs, and routines along with their corresponding tags. The first thing to understand about smart objects is that you can have multiple routines and multiple programs that reside inside of them. These objects are scalable and reusable and allow you to encapsulate large to small amounts of data. We can pass information in and out of the smart objects by using parameter connections. For those who are familiar with object-oriented programming concepts, smart objects provide encapsulation, abstraction, and inheritance of our code in FactoryTalk Design Studio. To contrast, if you think about the reusability that's available in Logix Designer, now you're probably thinking about subroutines or add-on instructions or AOIs. Subroutines and AOIs also allow encapsulation, abstraction, and reusability, but you only have a single routine associated with those objects. Smart Objects expands on that idea and allows you to create larger encapsulated groups of code. FactoryTalk Design Studio also allows for tags to be scoped at the routine level. So to summarize, Smart Objects allow modular, object-oriented programming to be used as your logical project design dictates. Next, let's look at how FactoryTalk Design Studio is based on a logical, hardware-abstracted design methodology. We want you to be able to design your project based on what that system is doing and not be focused on where it is executing. We think there's a lot of value to designing your project logically. You will be able to deliver a project that is very easy to understand. By looking at the system model, you are looking at what the system is doing and be able to troubleshoot the system that way. In addition to that, you can also build your project based off of what it's doing and worry about how it is executed later. If you have created a Logix project before, then you have seen that you need to start by defining what controller you're working with. We have changed that workflow in FactoryTalk Design Studio. You are able to map out the system operation, create your logic, then add your controllers and hardware later. You will bind the logical content to the execution devices using a process called allocation. Let's step through that process of creating and allocating code. We start in the system view where we create our smart objects. These smart objects represent the logical operation of the system. Our project is a clean-in-place system. CIP 100 represents our clean-in-place system, which has child smart objects. These child smart objects are for the wash, rinse, and acid tanks. CIP 100 is the highest level of our system. If we expand out this smart object, we see the child smart object of TK 100 wash tank. This smart object has more children's smart objects. The logical organization is what is important here. Imagine if we have an issue with the V101 outlet valve in the TK100 wash tank. We keep looking through the logical hierarchy until we get to the routine for the V101 outlet valve. The smart object allows for parent-child relationships in the logical model. So after I create my content as shown in the system viewer on the left, I can select the content I want to allocate to my controller. Once I have selected my content in the system view, I can select my controller where I want to allocate this content in the properties pane in the lower right. If I ever want to change this allocation, I simply change the controller selection. We will try this out during our lab session.
The next topic I want to talk about is integrated libraries. When you think about object-oriented programming, you often need the ability to manage those objects in a library. That's what the idea of having an integrated library means. You don't need to go to a separate product to manage these definitions or instantiate them into your project. What you can do is create those definitions directly in the FactoryTalk Design Studio library. You can see from the screenshots here that we still have AOIs and UDTs. Those are still available from the library, but the smart objects can now also be managed from the library. We will see how to instantiate smart objects in a few slides. But first, let's look at one other topic, how we share data between objects.
Once again, when looking at object-oriented programming techniques, some key pillars are encapsulation and abstraction. To encapsulate and abstract your content in an object, you must provide a mechanism to share data outside of an object and also hide data inside the object. How this is done in FactoryTalk Design Studio is using parameters and local tags. Tags can be defined at both the program and routine level, but those defined at the program level can be designated as either local or shared. Local tags are not visible outside of the program, where shared tags can be set as input, output, or in-out, which allows for connections to the smart object from external sources. These connections can be set in the property pane. Now that we have smart objects in our library, we need to be able to use them in our project. It's quite easy to instantiate a smart object into your project. In the system view, as seen on the left side of the slide, the user creates a new smart object. The Smart Object dialog box appears, and after the name is entered, the user can select Create an Instance from a definition. Once the definition is selected and the smart object created, it will be placed in the project in the system view. Notice how the smart object icon is two linked hexagons to indicate it is linked to a smart object in the library. This is a good time to make a quick look at instantiated versus singleton smart objects. A singleton smart object is a standalone object that acts as a hierarchical container in the system view. A singleton is identified by the icon of an outline of a hexagon. When a smart object is defined in the library, it is shown as an icon with a filled-in hexagon. When a smart object is inherited from a library object, the smart object's icon are two linked hexagons. I know you may be saying, do I really need to know this much detail? The next slides will answer that question. Another key aspect of object-oriented programming is inheritance. All this talk about instantiating and inheriting smart objects is necessary to implement inheritance in FactoryTalk Design Studio. An important part of inheritance is being able to break inheritance. Imagine in your project you have an object which is inherited from a library. In this example, we have a valve object. Let's imagine that we need to make a change to that instantiated smart object, but we don't want to change the definition. That would change all the objects using that library module. Instead, we break inheritance. In this case, we right-click on the object and choose Override Program. This allows us to change the specific program without affecting the library definition. Another important aspect of inheritance is combining objects together to create new objects. You might want to combine multiple objects together or add content to a current object. In this case, the original library object does not change. This process is called extending an object, and that is also supported in FactoryTalk Design Studio. In this example, the pump object is used from the library, but the pump test smart object is added to the caustic pump smart object. Now imagine we take the code we just created and we want to create a library object from that. Guess what? We can. If we right-click on the smart object and select Add to Library, we can add this new code back into the library. Better yet, we still have the original definition as part of our new smart object, so if changes are made to the library, those changes will be inherited in the new object. That is object-oriented programming at work. We have gone over a lot of items here, so let's take a moment to recap all we have learned. Smart objects are setting the foundation for the modern software experience in FactoryTalk Design Studio. They provide the basis for a modular, scalable design environment. They can be standalone or inherited from the library. They expand on the idea of the AOI but can encapsulate other smart objects as well as multiple programs and routines. Smart objects allow you to create a logical hierarchy that's easily understandable. They can be created in the integrated library so they are easily transported and instantiated. They can be extended to account for differences in the project design. They can interact with other smart objects by passing data in and out through a program parameter connection. They continue to be expanded on through future iterations of the product. Finally, the integrated library currently supports one project but will be expanded in future updates to be shared among many FTDS projects, users, and organizations.
As we mentioned earlier, many programmers working on automation are more comfortable with text-based programming. FactoryTalk Design Studio allows those users who are familiar with text-based programming to easily transition to automation programming, which has been traditionally done with graphical editors. And for those who prefer the graphical displays, those are still the default. When making changes in the code editor, the text is automatically rendered in the graphical display. This feature provides the flexibility for each developer to choose what programming method is best for them. As mentioned earlier, Integrated Version Control System allows native multi-user collaboration, allowing the user to easily share code while maintaining code synchronization. We use Git technology as our integrated version control system. Having integrated version control allows you to track all of your project changes, You can see in the screenshot on the right that there's a description, there's the time and date stamp of when the edits occurred, and there is the person who made the changes in the form of their email address. You would expect to see all of this information as part of your project change history, and all of that is captured as you are editing and making commits into your projects. If you're not familiar with the idea of a commit, it is a milestone in your project. It is a known good state. The commit allows an increment in the change history to see who's making changes and what they're doing to the project. It also allows detailed comparisons. You can see in the lower right the comparisons of one point in history to another point in history. I can take my latest changes and compare them to several changes ago. Maybe that's part of a troubleshooting effort, or maybe I'm just looking to make sure that I understand the changes that have occurred at a certain point in time. Currently, the comparison is in the text editor, but in future releases a graphical compare will also be available. To look a little closer at the change comparison, highlighted content calls out a change in the line of code. Gray slashes indicate nothing was in the project before and now there is something in the new version. Any highlighted line indicates something has changed. Going hand in hand with version control is the topic of multi-user collaboration. This integrated version control system enables native multi-user collaboration, allowing the user to easily share code while maintaining code synchronization. As we just covered, FactoryTalk Design Studio also includes integrated project tracking, allowing users to see all local and remote changes by other members of the team. You can merge your local edits with the shared project and merge changes made by other users. This feature provides design flexibility and improved collaboration while developing applications. For those who are familiar with Git, the ability to have multiple users collaborating on a single project is not new, but we recognize Git is oftentimes a new concept for automation users. So we are trying to make it simple for those users. We have added icons highlighted at the top, where with a single click you can merge, push, and pull changes, or bring up the current change history. In the bottom right-hand side of the screen, a statement of the status changes is displayed. This indication helps the user to understand what project changes are available in the system. I thought it might be a good time to provide a brief overview of the differences between the shared and local changes that could happen in a cloud system. All developers have simultaneous access to the shared project, which is shown in the cloud server. When a user makes changes in their local repository, that change is still in the cloud, but not yet merged with the shared project. When a user makes a change, they will first make a commit, which is a point which adds a line to the revision history. You have the ability to revert back to a previous commit point if necessary. If changes have been made by a remote user, a pull will merge those changes into your local copy of the project. Conversely, if you make changes and want others to have access to them, you will need to push your changes to the shared project. At any given time, you can view the change history and see the status of the shared project. I thought it might Being as version control and Git are somewhat new concepts in automation programming, FactoryTalk Design Studio provides clues as to the status of the project. The icons in the toolbar indicate when you make changes that a commit or push are available, or if changes were made by a remote user, an indication that a pull is available will be displayed. A status message is always present in the bottom right of the editor window. One other situation a user may encounter is if the local and remote user both make changes to the same code. This window aims to resolve those conflicts when multiple users are working on a project simultaneously and allows the user to determine which is the best change to keep in the project.
As mentioned earlier, with a system-focused approach, FactoryTalk Design Studio enables multiple controller management in a single project. We recognize that the complexity of the systems you are building is always growing. Having a project based on its logical operation rather than its execution drives managing everything in a single project file. We also know that every controller in a project may not all have the same controller firmware. So having all of these controllers in a single place means that we also need to make sure you can connect to that firmware regardless of the software version. Earlier, when I was talking through the idea that we would always have the software up to date, you might have been wondering about the firmware. The answer is that starting in version 34, FactoryTalk Design Studio will be able to manage all the firmware versions for you. If you try to allocate functionality that is not supported in a controller firmware, a validation message will be generated. The other issue with multiple controllers is how to allocate your programs for the controller. Each program can be allocated individually. So if you need to expand your project to include more controllers, no problem. Allowing for control over how programs are allocated to the physical controllers improves logical project organization and optimizes deployment. We have looked at the system view and the library editor, so let's look at the Devices Explorer. The Devices Explorer is where we can add controllers and other I/O to the system. To add controllers and I/O, use the dialog shown. What is nice about this dialog is you can add filter by category and select multiple types of devices. For each device type, you can add multiple quantities at one time, so it is very easy to add your devices efficiently. Another benefit of FactoryTalk Design Studio being a cloud-native application is that all these device profiles are accessed directly from your web browser. As new profiles are available or updated, they are immediately available without updates or downloads. There is a new concept in FactoryTalk Design Studio that may not be familiar if you're coming from Logix Designer, and that's the concept of unassigned devices. Whenever you add devices into Logix Designer right now, you either install the module into the back plane or you add them as Ethernet device. In Design Studio, we focus on the logical design of the system, which means we provide flexibility with how you will manage your physical devices. You know you will need an output module and an input module, but you might not know which controller owns which modules. Or it may be possible you don't want to choose a controller until you know the size of your project. In FactoryTalk Design Studio, we give you the ability to add devices to the project without having to assign their ownership. This ability is called an unassigned device. Having the devices unassigned allows you to move the device without losing all of the configuration of that module. The last part of the Device Explorer I want to mention is the device list. If you're looking at this Explorer over on the left, or if you're familiar with the larger ACT project, it can be difficult to manage a long list of devices. If you have a controller that has a large number of I/O modules, that list is going to get pretty big, and it will be hard to maintain. In FactoryTalk Design Studio, we are introducing the idea of the device list, which is exactly what it sounds like. It's just a flat list of all the devices that are in your project. But instead of being in that tree form, which might be a little bit hard to navigate, you can see it's a flat list shown here on the right. The list gives you the name, descriptions, catalog numbers, firmware revisions, category type, vendor, and electronic keying setting. This list can be sorted by any of these columns, which allows you to view the information as it is important to you. Alright, so now we have looked at a high level of the features of FactoryTalk Design Studio. What's next? We have a hands-on lab to go even deeper. There are 3 main sections to the lab which will help you become familiar with the application and the key features we discussed in this presentation. The hands-on lab system simulates a potential clean-in-place skid as shown in this diagram. There are 3 tanks, a rinse, sanitize, and wash tank. We will also have a caustic solution we will be adding to the process. The items highlighted in blue will be the components we will be controlling in our lab project.
That concludes the presentation section of our lab. We from Rockwell Automation want to thank you for participation, and we wish you a great day.